All right. This is problem 1B on a summative review. All right. And then this would be video 2. All right. But that doesn't matter. You look at what you need. So this covers problem 1B. And if we have time, we'll get to 2A as well. Let's look at this. So we talked about greatest common factoring. Okay. And the greatest common factor factoring. Sorry, that sounded weird. And so what you always need to do is you need to distinguish which factoring method you're going to use, right? Because we have two main factoring methods that we're focusing on for this, and that's either greatest common factor out of everything or it's some kind of a grouping method, right? And the main grouping method we use is the AC method, right? The AC method. And so when you look at both of those methods, right? And GCF is actually part of the AC method, but what I mean by this, as far as the overall methods, is it's all you do, right? There's no grouping involved. So what you do to determine which one you got to use, right, is you look at, okay, look at your coefficients and your constants. Is there anything I can pull out of both of these number-wise? And it's like, well, no, not really, other than 1, right? 1 doesn't do anything for you. If you can't pull 2 out because they're both odd, you can't pull 3 out because 3 doesn't go into 25. And if you go through the rest of your numbers up to up to 9, you don't, there's nothing you can use. So there's no numbers you can pull out and you go, okay, well, what about a variable? Well, the problem is there's only a variable here. There's no variable here. So I can't pull a variable out. So basically, if all you've got in your toolbox is this thing is prime. You can't factor it. Well, this isn't all we have in our toolbox. We also have the AC method. So when you find something and you can't factor it with this, it probably means that you can either factor it with the AC method or it is prime. So let's figure it out, all right? So before we start the AC method, I'm going to do this. I'm going to go ax squared plus bx plus c, because this is my general quadratic equation, right? This is my general form for my quadratic equation. A is your coefficient in front of that, right, in front of your squared term. B is your coefficient in front of your non-squared term, right? And we're using h's, but it could very well be x. And c is your constant. C is the number that is by itself. So we got -9 here. So in this one, right, we don't have a b term. So that doesn't mean it's not a quadratic. It just means we don't have a b term. And the reason we don't have a b term is because in this one, b equals 0. So if I go through this, I would say a equals 25. I would say b equals 0. And c equals -9. Remember, you're always including those signs. So signs to the left of all of your terms always belong to those terms, right? So it's like previewing this. It's saying, hey, the upcoming number or monomial or whatever it is negative or it's positive, whatever it is. So these are the numbers I'm going to use, okay? So now the AC method says that what we are going to do is we are going to multiply a times c to get what we call AC, right? And you'll simplify it. And then the next step, right? So that's the first thing you're going to do. And the next step is you want to pull out a pair of factors that add up to b, right? On a pair of factors that adds up to b, right? And so I think about this and I go, okay, well, my b is 0. So in this case, I need a pair of factors that add up to 0. And I will be able to get that because I'm going to have a negative AC term, which means one's positive and one's negative. So that's going to work. All right, so let's try this. All right, so if I go a times c, in this case, it's going to be 25 times -9. You got to include that sign, right? Which means that that is equal to -225. All right, and so now for my step 2, right, that means that I have -225. I want to find a pair of factors that add up to b. Well, you can go through this and pull like 1 and 5 out, and I think you can pull 3 out of this, and you can probably pull 9 and a bunch of things out of this, right? But all of those are going to give you like a larger second factor and aren't going to add up to b, right? So for example, if you have -1 and 225, right? That adds up to 224. Right, when you add them. If you go -1 plus 225, that gives you 224. So we want two factors that are basically identical to each other but opposite sign, because it's the only way you can get something to add up to b, and which in this case is 0. Okay, that's what we need, a b of 0. So that only works when you have a square number. Right? Because those are a square number is a number that you multiply the same number by itself, and you get that, right? And when it's negative, that means one's positive, one's negative. And guess what? This is a square number. You can get 225 by multiplying 15 and -15. So these are the factors we are now going to use, and we're going to do the next step where, if you remember this, we call this decomposing, right? So we're going to rewrite this equation, and instead of thinking of this as 25h squared minus 0h minus 9. We're going to decompose this O, 0h, into these two factors, right? And then you're going to see something happen. That's cool. We're going to say plus 15h minus 15h, and then minus 9, all right? And so now we're going to use our factoring by grouping. So factoring by grouping tells us that we are going to take this and we're going to split this, right? And we're going to factor this one using greatest common factor, and we're going to factor this one greatest common factor. And we want the same thing in our parentheses. We want to get the same thing in our parentheses, and that's also called a factor too, but it's a little confusing to call it that, right? Because we think, oh, greatest common factor is the thing out front, but the thing in the parentheses is also a factor because it's something you multiply. All right, so let's do this. Well, I can pull 5 out because 5 goes into 25 and 15, and it's the largest thing that goes into both of them. And I can pull 1h out. I can't pull more than 1 because there's only 1 here. So this is going to give me 5h over here to get to 25, because 5 times 5 is 25. H times h is h squared. Plus, and all I need to multiply this by to get to this is 3. All right? So we've got 5h plus 3. Okay? And now on this one, the goal is to get this same factor, right? To get this same 5h plus 3. This is our goal. This is what we want. We want to get this because we have it over here. Okay? And so I always go ahead and write it down, and like expecting that I should be able to get this, right? So now let's try to get it. So if we have 5h, what do we multiply by 5h? That's going to give me negative 15h. Well, the only thing I can think of is negative 3, right? Because negative 3 times 15 gives, negative 3 times 5, my bad, equals negative 15, and then the h gets tacked on. So now just make sure that the same thing works with this to get this. And negative 3 times positive 3 is negative 9. So it works for both of these. This multiplies out to give us this. We have the same factor. And so now my last step is I can pull that common factor out front, that 5h plus 3, and I can multiply it by what's left, which is 5h minus 3, and you have a completely factored, you have completely factored this binomial. All right. Now, spoiler alert here. When you look at this problem, okay, when you look at this initial problem right here, some of you hopefully will be able to recognize that, wait a minute, this right here is a square number, this is a square term, and this is a square number. And when you see that, okay, that means that you can go immediately to figuring this out, right? You can say, well, if that's 25 You take the square root, you put both of those here. You take the square root of your variable. Square root of h squared is h. And then square root of 9 is 3. And then you just do the difference of squares. So difference, different signs. So plus, minus. And then that will get you right to this form. All right, so hopefully this helps you guys. Looking forward to doing some more of these with you. Sorry about the length of this, but we're kind of covering the AC method and this case, all right? And so we will use the AC method a few more times in these videos. So thanks.